talk about some random sections and kind of go through the review sheet and see what we have. Okay. So drawing angles should be pretty good. People may not remember something like number 2 though. Find the length of an arc. And this one is actually, again, not as bad as you might think. An arc of a circle of radius 12 inches with a angle of pi over 4. Remember that looks kind of like this. And the radius is 12 inches. The angle is pi over 4. Remember the whole idea of a radian? Is a radian is just the angle that makes this that many radii. So you always just multiply them together. It's kind of like unit conversion, right? We have pi over 4 radians. Right? And 1 radius is 12 inches. Okay. And then we multiply these together and we're going to end up getting 3 pi inches is how long that arc is. Okay. So that's sort of the definition of a radian. That's what we mean when we say radian. There's a bunch of other ways to talk about what radians are, but that's kind of like one of them. So that's for arc length. For degrees, you can convert it to radians, but it's the same idea. But convert between radians and degrees. Again, that's unit conversions. Pi radians is 180 degrees. For area is not as nice. Okay. So a sector is a central angle of 30 degrees and a radius of 20 centimeters. What's the area? Right. 30 degrees. Maybe something like this. Radius of 20 centimeters. You just find the area of the whole circle and then figure out what portion of this, right? This is 30 over 360 degrees of a full circle's area. So just find the whole area of a circle and then multiply it by this percent, this ratio, this fraction. Okay, right? This is 1/12. It's 1/12 times pi r squared. So 1/12 times pi times the radius squared. And that's going to be something. And then remember, always express your answers in units. So it's something centimeters squared. Okay. Again, if anyone has any questions, feel free to jump in. If there's a specific problem that you want me to do, I'll do the specific problem. Otherwise, I'm just going to keep on bouncing around. These application problems in 7.1 are essentially just unit conversions. Okay. So watch out for the unit conversions. Like 11, for example. 11 says we have a wheel with a 24-inch diameter, right? That is a 12-inch radius. Radii are much more useful than diameters. And it's rotating at 0.5 radians per second. Question is, what is the linear speed? What is it in RPM? And what is it in degrees per second? So linear speed, right? Well, we have 0.5 radians per second. We just need to convert that to linear speed. So unit conversions. 1 radian is 12 inches, right? Now we multiply this out and we get inches per second. All right. And we could convert it the other way, right? If we wanted it in RPM, rotations per minute. Again, we start with 0.5 radians per second. And then how many radians are in a rotation? We want rotation up here. Well, 2 pi radians are in 1 rotation. So then the radians cancel. Now we're left with rotations per second. We need to get rid of seconds. We want it to be minutes. So 60 seconds are in 1 minute. Then the seconds cancel. And again, we get rotations per minute once we multiply that out. Okay, that's the idea here. You can do the same thing for degrees per second. You just do unit conversions for all of these. Goodness. All right. So again, 7.1 has a lot of stuff in it. 7.2, cofunctions. Remember the cofunction identities? You'll have access to these sheets. Cofunction identities say that the sine of a complementary angle is a cosine of that other one. So the cosine of 34 degrees, what's the complement of 34 degrees? It's what adds up to 90 degrees. Yeah, we still got edging going on right outside of my window. So the complement is going to be 56 degrees. So cosine of 34 degrees is equal to the sine of its complement. Cosine of pi over 3 is the sine of its complement, which is pi over 6. What adds up to 90 degrees, pi over 2. Okay. Solving triangles. This should be pretty straightforward for people. Solve triangles. Application problem, just draw a picture first and solve a right triangle. I'm very confident that you guys can do this. Exact value of this, you can use your calculator, but make sure that you're not using an approximation if you're using a calculator. If you're not using a calculator, you just use those reference triangles, right? I'll always give you the reference triangles, right? If you don't have them, you can always ask for them. All right, this is what they look like. So the cosine of pi over 4 is just 1 over root 2. The tangent of pi over 6 is 1 over root 3, okay, and stuff like that. And then for quadrantal angles, right, if you're looking at sine of pi over 2 or something, you just draw the unit circle. Pi over 2 is 90 degrees. It's right here. And sine is the y value on the unit circle. On the unit circle, this is the point 0, 1. All right. And that's how you approach something like this. Reference angle. I think people are good with reference angles right now. Watch out for radians, though. On your final, if you're asked to find a reference angle, it really might be helpful if you convert it to degrees. Radians can be tricky. But if you're confident, go ahead and do it in radians. Sine and cosine of these angles. You're good to go. Remember these ones? These ones are kind of tricky, and I really like these ones. Something like 24. If you're given a cosine or a sine, how do you find the other things? Let's look at that really quickly. 24. We know that cosine of t equals 2/9, and t is in quadrant 4. You just draw a picture. Some triangle in quadrant 4. I don't know what the triangle is. Cosine is adjacent over hypotenuse. We need to find this y value. 2 squared plus y squared equals 9 squared. And you solve that, and you're going to get y is the square root of 77. Remember, the y coordinate's negative in the 4th quadrant. So sine of t then is just opposite negative root 77 divided by hypotenuse, which is 9. Simplify this radical if you can. But this is just 11 times 7. It doesn't simplify. Okay, so just draw a picture and get it like that. Another thing to watch out for, right, is with these reciprocal functions. If you're using a calculator for a reciprocal function, be very, very careful, right? This first one on 26, the secant of pi over 6, right? That's not, definitely not the cosine of 6 over pi, right? This is important. This is a very common error. While 6 over pi is a reciprocal of the angle, that's not what reciprocal functions mean. If you're using your calculator, secant of pi over 6 is 1 divided by cosine of pi over 6. Or another way to see it is cosine of pi over 6, right? Is root 3 over 2. So secant of pi over 6 is equal to 2 divided by root 3. All right, so watch out for these reciprocal functions. Yeah, they're big stuff for the exam. I think this stuff was pretty good. 8.1, we started getting into graphs. You remember graphs? We talked about amplitude, period, midlines. We talked about phase shifts. Can you graph these functions? Do you remember what we talked about for graphing? Let's look at these graphs real quick. I'll zoom in a little bit so we can see them a little bit more clearly. So amplitude. Amplitude is related to the height, but it's not just this height, right? The amplitude of this graph is not 4. Amplitude is how far up do you go from the middle and how far down do you go from the middle. So our midline here is the line, the horizontal line, y equals 3. I have a cat hair on my nose. The midline here is the horizontal line, y equals 3. So we go up 2 to get to the maximum and down 2 to get to the minimum. All right. So that's midline. That's amplitude. Okay. We also talked about period. Period is how long does it take until the graph repeats. You just pick 2 points that are in the same spot. But be very careful, right? These two are not on the same spot, right? Because this one's going down, this one's going up. Yeah, we'll definitely spend some time. I think that's 8.2, but that's a good suggestion. Let's do that right after this. So again, it's at the bottom when x is 0. Also at the bottom when x is 5. So the period's going to be 5. Okay. And phase shift, right? If this is a cosine graph, it should start right here. So you can think about this as a phase shift 2.5 to the right. Okay. Or you can just write it as a negative cosine function. Okay. And then remember how we found these things. This is related to the period, but it's not the period. Right? Period is 2 pi over b for sine, cosine, cosecant, and secant. The period is 2 pi over b. For tangent and cotangent, the period is just 1 pi over b. And the reason why is because these functions normally have a period of 2 pi. These functions normally have a period of pi. Okay. Yeah, let's look at the tangent and stuff. The real quick, these are the 4 like harder functions. The reciprocal functions and tangent we're in 8.2. Tangent's the one that's centered. Okay. Cotangent is very similar to tangent, but just a reflection and a phase shift. And again, this is going to be cosecant because it's the reciprocal of sine. And sine is 0 at 0. Right? Sine starts in the middle, if it can be thought of to start anyway. So cosecant is the reciprocal. The reciprocal of 0 is undefined. That's why we have an asymptote right there. Whereas this is secant. It's the reciprocal of cosine. Cosine starts at 1. The reciprocal of 1 is still 1. So going on here. Okay. Let's talk about some tangent graphs real quick. I need to figure out where this cat hair is on my nose and get rid of it. All right, so tangent graphs. If we wanted to find the equation of a graph like this, okay, we need to find the stretching factor, which we'll talk about. We need to find the period. We need to identify a phase shift if there is one, and maybe there's a vertical shift. Okay. So this graph right here, we know there's no vertical shift because the middle of the tangent function is still at 0. But there might be, who knows? There might be a stretching factor. There might not be. For other graphs, stretching factor is easier to see. For the reciprocal functions like this, stretching factor is just where are the bottom and the tops at. Right? For cosine and sine, the stretching factor is the amplitude, okay, which is half the distance from the top to the bottom. The amplitude here is 2, right? Because the midline's 1, distance from the midline. Amplitude here is 2, distance from the midline. Amplitude here is 4. The midline is the x-axis here. But for tangent, finding the stretching factor is a little bit more complicated. Okay? What you want to look for, goodness, couldn't get that. I don't know where the hair is. Here, the stretching factor, what you look for the stretching factor is look at a quarter of the period, or half the distance from the middle to an asymptote. So what's the y value? Half the distance between the 0 and the asymptote. So we look at the y value right at this x coordinate. And it looks to be, I don't know, about a half. If you said like 2/3 or something, I'd still give you points. As long as you made a guess on what this y value is. Something like this, our stretching factor would be, what problem is 35? Something like this, number 35. We'd say our stretching factor, our a value, is 1/2 right here. And what you want to do for tangent, look at the y value, halfway between center and an asymptote. Okay. And the stretching factor is usually the harder one. But then let's also look at the other ones, right? We need to find the period. So we're trying to find the equation here. So we need the period so we can find our b value. The period is just the distance before it repeats. So it goes off to -infinity here, goes off to -infinity here. What's the distance between these 2 points, these 2 x values? The answer is 0.01. So here our period is 0.01. But this is not our b value, right? This is not our b value. The period is pi over b. So if we know the period, we need to use this to solve for b. Okay, so multiply both sides by b. You get 0.01b equals pi. Divide by 0.01. You get b is 100 pi. Okay. So we know our function then must look like y equals 1/2 a times the tangent of b, which is 100 pi, times x. There's no phase shift. There's no vertical shift. So this is what you get like on 35D, I guess. All right. Does that kind of answer your questions about tangent graphs? Or do you want to talk some more about them? One other thing about tangents, right, is you could be asked, theoretically, something we talked about is find the equation of all the asymptotes for a graph. It's unlikely that I'm going to ask a question involving this right here. You should still be able to graphically, though, identify the asymptotes. Right? You should be able to say, okay, the asymptotes are at negative 0.005, 0.005, etc. Or, oh, okay, the asymptotes are at x equals 0, x equals pi over 4, x equals pi over 2. Or if you want to be flashy, you can say x equals pi over 4 times k. Okay. That's more important, but it's less likely that I will just give you an equation and say, hey, find the asymptotes. Other stuff we can talk about. Ooh, yeah, remember inverse functions with these weird rules we got right here. Okay. You don't need to use a calculator, but you could. Right? Just make sure you're giving me exact answers. If you answer x equals 0.8632179 dot dot dot, it's not an exact answer. And I will mark off points. Your answer should be like negative pi over 2, pi over 6, 30 degrees, 45 degrees, 80 degrees, etc. Probably not 80 degrees. Okay, that's the idea for these. So if you're doing these by hand, I imagine not very many people are. If you're doing these by hand, you have to remember what the range of inverse sine is. Can you use something in the first or the fourth quadrant? Inverse cosine will be first in the second quadrant. Okay. More interestingly is when we have these compositions like this. You just work on the inside and work your way out, right? So if we're looking at like 36, and then something like D, you have the inverse tangent of the sine of pi. You just do it one step at a time. Right? Pi is 180 degrees. It's a quadrantal angle. Sine is the y coordinate. The y coordinate here is 0. This is just inverse tangent of 0. And again, this you can type in on your calculator or do it by hand. Tangent of what angle equals 0? And it's going to be 0. Okay. 0 degrees, 0 radians, same thing. That's how you do something like 36D. And they can be a little trickier if you go at them from the other direction, because I need exact answers, right? So something like F, I don't need to show you F, I can just write it down. These are really good ones. There's almost guaranteed to be something like F on the final, which I'm writing later today. Something like F, if you're taking the inverse or the sine of the inverse cosine of 3/5, again, almost for sure going to be on the final. Not this problem, but something like this. Okay. There's no exact answer for this. This is going to give you some angle. Okay. We don't need to even know what the angle is. All we need to know is what is the sine of this angle. So we draw a triangle, right? If we have some angle is the inverse cosine of 3/5, well, that means that the cosine of that angle is 3/5. And we just need to figure out what is the sine of that angle. Well, if the cosine is 3/5, cosine's adjacent over hypotenuse, this side has to be length 4, 3, 4, 5 triangle. So the sine of that angle is 4/5. And that's how you approach these ones. If there's numbers, you do it like this. If there's variables, you do it the same exact way. Okay? Right? If there's variables, something like J, what is the cosine of the inverse sine of 1 over x? This is a really good problem for anyone who's going on to calculus. These pop up a lot in trig substitutions and trig integrals. Okay, so you do the same thing, right? If this is some angle, well, we know sine inverse of 1 over x is going to be some angle, which means the sine of that angle is 1 over x. You just draw a triangle. Sine is opposite over hypotenuse. We need to find the cosine of this angle, so we need this adjacent side. So Pythagorean theorem, adjacent one side plus the other side squared was the hypotenuse squared, and you just solve for this other side. So it can look kind of ugly. And remember, you can't simplify square roots. There's addition inside. So this is as simplified as it gets. Square root of x squared minus 1. So the cosine of that angle is the adjacent, which we just found, over the hypotenuse. Like so. Any questions on these or any other specific problem requests? Otherwise, I'm going to keep on going. Okay. Find theta. These ones were a little trickier this semester than I expected. You just want to set up a relationship and then use inverse functions. Okay, so like you have a triangle like this where this is theta, this is 19, this is 12. Start with what you know with trig, that the tangent of that angle is 12 over 19. Do not write the tangent of 12/19. This is meaningless. We take the tangent of angles. We do not take the tangent of ratio. Don't do that. The tangent of that angle is opposite over adjacent, 12/19, which means theta is the inverse tangent of that ratio. Should always be an angle on the inside of trig. Should always be a ratio on the inside of inverse function. Okay, and then again, you just type that into your calculator and watch out. During your final exam, you're going to switch your calculator between degrees and radians multiple times. Some problems you're going to want to use degrees. Some problems you're going to want to use radians. I will almost never specify which I want you to use. You can almost always use whichever you prefer. Sometimes one will be easier, okay? So make sure, always, when you start your exam, just make a note at the very top. I don't care. Make a note at the very top. Hey, make sure to check degrees or radians. Very common mistake, even this late into the semester, okay? Anytime you're using your calculator, just double check. Or at the end, before you take a picture, just go through all your answers. Every time you use trig, check. Did I use degrees? Did I use radians? Okay. And if you're using degrees, make sure to include the units. So if you're using degrees, have that little degree sign up there. All right. And again, these applications in 8.3 are the exact same. You just draw a picture. Do the exact same thing. Do not forget units. Okay. Units for applications. I'll write that down. Anytime the problem gives you units, your answer should also include units. Feet, meters. Those were apparently the only two units that popped up into my head. Okay. That brings us to chapter 9. Yeah, you can ask that, Tyler. I haven't written the final yet. I don't have I don't care whether you know how many problems there are, but I don't know yet. If you want to remind me tonight, I'll have your final written by then and I can tell you. But realistically, what I'm going to do when I write the final is I'm going to just grab one problem from every section, probably, unless they're short. And then I might do a couple. I'm going to give you 3 hours, but my intent is that nobody takes anywhere close to 3 hours. Okay? But I don't want people to be rushed on the final. How many sections are there on the final? I don't remember. 1 or 2 problems from every section, depending on how long they are, I imagine. But yeah, if you remind me tonight, you just post under like the 1405 questions on the Discord, or just DM me. If I remember, I'll just tell you. If I forget tonight, I'll have the final. I can just tell you the answer, but I don't know yet. That's kind of what I'm shooting for. My goal on the final, and I think I've mentioned this before, my goal on the final is to have a balance. I don't want the final to be long. You don't like long finals. I don't like grading long finals. But if the final's too short, then one mistake like takes you down a whole letter grade, which is also not good. So trying to find that balance of, I don't want the problems to be worth too many points, but I don't want your exam to be that long. Yeah, this gets into chapter 9. Again, you can use this identity sheet. Big note on the identity sheet, before the final, if you want to write explicitly the half angle formula, go ahead. This can be used for the half angle formula. But if you want to explicitly write it down on your sheet, go for it. Right? And I've mentioned this before, but real quickly, right? Sine squared of an angle equal to 1 minus cosine of double that angle over 2. Right? Equivalently, you could also write this as sine of theta over 2, where just u is theta over 2. And then square root both sides. So plus or minus 1 minus cosine of double this. What is double this angle? Just theta over 2. Or remember, this plus or minus, choose 1. So if we're in the first quadrant, sine's positive in the first quadrant, so use the plus. If we're in the third quadrant, sine's negative in the third quadrant, so you're going to use a minus. Okay. You get the other ones, but you have trouble with the verification ones. Okay. There will be some verification problems on the final. There's also going to be a lot of there's going to be a couple of the ones like this. These are also tricky, right? If I give you information about the sine and the cosine, use the identity. But I think by the last quiz that we were doing stuff like this, the first quiz that we did stuff like 46, I'm showing you guys, you can't see. The first quiz we did stuff like 46 like this, it was really, really bad. But by the last quiz, almost everyone was getting it. So there will be more stuff like this. But yeah, there will be some verifications as well. So that's good. That's good. And realistically, because again, I'm writing your exam later today. Realistically, probably only a couple verification problems, and they're probably not going to be very complicated verification problems. The verification problems in this book, compared to the other book I used before, I think are simpler on average. We can do some for the review as well. And you might get something like this, just simplify some stuff. Put things into sines and cosines. That helps a lot. Okay, so like something like C is a good one. Talk about 42C. You're simplifying this. Cotangent of T. I'm going to change it to theta. Trig with T's looks so confusing. What's tangent of theta divided by the secant of negative theta? So there's a lot going on here. You just put everything in sines and cosines. It can get a little simpler. Also, as soon as you see a negative on the inside, if you ever see a negative on the inside, ever, when the problem is given to you in your final answer, say negative on the inside, let's deal with that. Parity identities. Secant is an even function, 1 over cosine, which is also even. So if there's a negative on the inside, it's the same as if there were no negative at all. All right. So I'm just going to do that first before I even put things in sines and cosines. Let's just get rid of that negative because it's an even function. Okay. Zoom in a little bit. It means I have to scroll more. Hopefully it'll be easier to read. And now we just put things in sines and cosines. So cotangent is cosine over sine. Tangent is sine over cosine. And secant is 1 over cosine. And we have a complex fraction. Complex fraction means fractions inside of fractions. And there's 2 ways we talked about dealing with this. We can either multiply the top and the bottom by the LCD, which will be sine theta cosine theta, or we could write this as a division problem. Up to you. Okay. So, a lot of different ways of approaching this. Another way of approaching this is to really just multiply by cosine of theta over cosine of theta. Whatever you prefer. Right, because if we do this, we have to distribute it on the top. And remember, it's like cosine of theta divided by 1, so it only goes into the numerator. This becomes cosine squared of theta over sine of theta. This becomes sine of theta times cosine of theta over cosine of theta. And this becomes, well, cosine divided by cosine. All right, so our whole denominator cancels out to 1. This right here also cancels out. We're left with cosine squared of theta over sine of theta plus sine of theta. All right, and we can simplify further using Pythagorean identity. If we put everything in terms of sines, this will get a lot nicer. So what we're going to do, cosine squared is 1 minus sine squared of theta. And remember, right, if you have subtraction on the top, you can split up the fraction. If you have subtraction on the bottom, there's nothing you can do. It becomes 1 over sine theta minus sine squared over sine theta. And one of the squareds cancels with the denominator, so we get sine theta minus negative sine theta plus sine theta, which just simplifies to cosecant theta. So, goodness, we just got a big cloud. There goes my lighting. All right. So that's like the hardest thing that you could see from like a simplification standpoint, probably. And most of the difficulty in the simplification and the verification is just algebra, not trigonometry. Okay. So watch out for those. And for the identities, remember, you always start with a side that you know how to work with. Sometimes it's the messier side. And then try to get it to the other one. Let's look at 43C. Okay. Let's go on a fresh piece of paper so I don't have to move it over. 43C. All right, so we want to show cosine squared of x minus tangent squared of x equals 2 minus sine squared of x minus secant squared of x. So I'm going to talk you through like my rationale for which side to start with. Again, you can start with either side. Okay. On the one hand, the side on the right has a 2. And I don't know what I'm going to do with the 2. Okay. I don't know what I'm going to do with the 2. So I kind of personally, Jason Barnett, wants to stay away from the right-hand side. I would personally start with the left-hand side. Okay. Just because I don't know what I'm going to do with that 2. There's no identity that says, oh, 2 is equal to this. Right? I would start with the left-hand side. Now let's look at where we want to go. Because sometimes when you start by simplifying. But this can't be simplified. This is simplified right here. So try to simplify if you can. If you can't, look where you're going. So I have a cosine and a tangent. I want a number somehow and a sine and a secant. And I know how to turn cosine squareds into sine squareds. Okay? Pythagorean identity is the most common identity you're going to use. It's the one right at the top. Right? Sine squared plus cosine squared of any angle is going to be 1. And again, we can move things around. We could move the cosine squared over to the other side. And that's the idea of what we're going to do here. We have a cosine squared, and we want to turn it into sine squared, Pythagorean identity. Right? Sine squared of x plus cosine squared of x equals 1. And I want to get rid of cosine squared. So let's move the sine squared over. Cosine squared of x equal to 1 minus sine squared of x. And this is also good news, right? Because now we have a 1. We needed a 2, but we're halfway there, right? The left-hand side, cosine squared, is 1 minus sine squared of x. We're still left with a tangent squared. So again, we have to keep on thinking, where am I at? Where am I trying to go? So we have the minus sine squared. That checks out. We have a 1 when we need a 2. And we have a minus tangent squared where we want a minus secant squared. You just go to your identities again. Okay? Do we have anything that relates tangent squareds with secant squareds? And we do, right? 1 plus tangent squared is secant squared. To do the exact same thing, 1 plus tangent squared of x is equal to secant squared of x. Well, I want to know what tangent squared is equal to. So subtract a 1 from both sides. Tangent squared of x is equal to secant squared of x minus 1. And I get a little nervous here, right? To see a minus 1, but I want a plus 1, but it's okay. Because what do we have on the left-hand side? We have 1 minus sine squared of x minus tangent squared. Tangent squared is this whole thing. You need the parentheses, otherwise you're going to get the wrong answer. Okay? Tangent squared, we said, was secant squared minus 1. Now that negative distributes, right? So it becomes 1 minus sine squared of x minus secant squared of x plus 1. And now we have that 1 plus 1 is 2, which is exactly what we wanted. That's the right-hand side. Okay, so that's just some review on like how to approach these verification problems. And the verification problems really are very similar to the prove or disprove ones. These ones are just a little harder here because if it says verify, right? If it says verify and I get something that's not the right-hand side, right? If I get like this with a 3 or something, and I say, okay, I must have messed up. But if it says prove or disprove and you get a 3, well, then you say, okay, did I mess up and it was supposed to be a prove? Or did I do it right and we successfully disprove? Okay, so these ones are the same idea, just a little trickier. Find exact value. You can use a half angle formula. You can use angle difference. Be careful to identify what is your theta when you're using the formula and write that formula down that you're using. Again, more verification problems. Here you could use angle sum on the left. Probably what I would do. Angle sum on the left-hand side. You could also try to simplify the right-hand side somehow. Same here. Use angle sum. The reason why I would use angle sum here, right, is because we have a tangent of x plus something. We have a cosine of x plus something. But on the other side, there's no x plus something. There's no x plus something. So we know we have to split this up. Okay, that's how you can identify that we need to use angle sum. Again, these ones are pretty big right here. You start with the formula. And remember, sine of x being 1/8 does not mean, yeah, let's do this. Just a little bit, right? For 48. If we need to find what sine of 2x is, given that sine of x 1/8 and x is in the first quadrant. You do not plug in 1/8. The only relationship between sine of 2x and sine of x is with the identity. Sine of 2x is 2 sine of x cosine of x. And now we can plug in because sine of x, that's the 1/8. Cosine of x, well, that's something, right? But we have to find it with the Pythagorean theorem. Square root of 63, which should be 3√7. And then you just evaluate. So you have 2 times 1/8 times 3√7 over 8. And just simplify. Okay. I'm writing very slanted. Half angle formulas, usually the trickiest for a lot of people. Watch out for them. Sine of pi over 8, for example. Tangent of -3 pi over 8 would be good. Right, something like 50c. Oh, goodness. That was loud. I apologize. 50c, right, is the tangent of -3 pi over 8. And it depends on which formula you're using, right? The identity sheet tells you that tangent squared of an angle, the formula sheet has u, is equal to 1 minus cosine of double that angle divided by 1 plus cosine of double that angle. So if this is our theta, then we just plug this in, and 2 theta will be -3 pi over 4. Or if you use the other formula, right? Tangent of theta over 2 is plus or minus the square root of this. Cosine of theta over 1 plus cosine of theta. This one's fine as well. You can use either formula, but you need to know which one you're using. All right, make these u's. So the most important thing if you're using these formulas is just identifying what your variables are. Okay, so if this is theta over 2, then what is theta? -3 pi over 4. And we can use that formula. Make sure to not go the wrong way, right? If theta over 2 is -3 pi over 4, or -3 pi over 8, how do we solve for theta? We have to multiply both sides by 2. And that's how you can find out what theta is. And that's how you get to -3 pi over 4. Anyway, so you get that it's plus or minus. Let's leave the plus or minus blank for a second. 1 minus cosine of theta, which we said was -3 pi over 4. And this is an angle that we can evaluate, divided by 1 plus cosine of -3 pi over 4. Now, what quadrant is this in? Is tangent negative or positive in this quadrant? 3 pi over 8. Maybe you know what 3 pi over 8 looks like. Maybe you don't. If you're feeling unsure, convert it to degrees, right? -3 pi over 8 in degrees is -67.5. Okay. Oh, I cannot see myself anymore. -67.5. What quadrant is that in? That's the fourth quadrant. Right? Theta over 2 is in the fourth quadrant, and tangent is negative there. That's how we know there's a minus sign here. All right, and then this is most of the points. But of course, you need to simplify. Watch out for these half angle ones too. They're going to be tricky for a lot of people. All right, and that's just about it. Everything else is more new. If you have questions, you can reach out to me on the Discord. I will be available. I'm going to try to be available as much as possible while you're taking your exam on Wednesday. Especially at the beginning, I will make sure I'm available. I teach my other class, and they're not having their final yet. I teach my other class at 1 p.m. So if I'm giving you 3 hours, then I can be available for the first 2 hours. If you have questions, you'll ask me on Discord or email. Discord's probably easier for most people, but email if you're comfortable while you're taking your exam, okay? I don't want you to sit there not knowing what I'm asking. So feel free to reach out during the exam. But starting at 1 o'clock, I will be teaching another class. So try to ask any questions you get in the first 2 hours. I don't think anyone's going to take more than 2 hours, but I'm giving you more than 2 hours if you need it. Okay. And yes, attendance, which I forget every single day. Let's see. What chapter do you feel the most confident on for the final? The attendance question today, so send it to me via Discord. Which chapter, 7, 8, 9, or 10, do you feel the most confident on for the final? Okay. Thank you for the reminder, Tyler. Yeah, and that'll be it for today. So good luck on the review. Let me know if you have questions. Attendance question, what chapter are you most confident on? And have a good day. Goodbye.